In this video, you're going to talk about patterns and rules of arithmetic sequences. Let's start by looking at the directions. You're going to discover the pattern in each picture. You're going to write a sentence or two describing the pattern and complete the table. Finally, you're going to see if you can discover the relationship between the stage numbers and the number of bars, puppies, flakes, whatever the image is. You're going to use your rule to calculate the stage at 50 and use the same rule to find the stage at which given puppy can happen. So let's take a look at this first problem. In the first problem, we have the number of bars. We see we have on the first stage 1, 2, 3, 4, 5 bars. On the second stage, why don't you try to fill it out? Well, as that answer is 9 bars. We see we have the 1, 2, 3, 4, 5, same as before. And now 6, 7, 8, 9. We added 4 more, it seems like. How many are in the third stage? Well, we see that answer is 13 in total. Again, from the previous stage 2, we saw that there was 9 here. We again have 1, 2, 3, 4 more. So it seems like every time we are doing what? We're adding 4. And we started with 5 bars. 1, 2, 3, 4, 5. It's important when you talk about a sequence, you have to have 2 different parts. Your start and how much you're going by. Those 2 things gives you a unique sequence of numbers. So what did we do to figure this out so far? First, we just counted and wrote down the numbers. Then we noticed that based on the previous one, I added 4 more each time, right? From the previous shape that we had, we kept adding 4 more. Assuming then that this would continue at the 4th stage, how many bars would it have? Well, it should have 17 because we added 4 more. Similarly, at the 5th stage, how many bars would we have? We see that that answer would be 21 bars. Again, 17 plus the 4 will be 21 bars. So what do we want to do? What we want to do now, we want to make a equation based on any stage number. I could figure out what number of bars there's going to be at that stage. I'm going to call that stage number n. So why don't you pause this, try to figure out what that equation might look like, and then unpause it and you can see what it's going to be. So when we make an equation, we often want to have our letters be representative of this. So this is one of the first things we're going to do. We're going to let n be our stage number. And for the number of bars, we could use b. I'm going to use n because we're going to be showing the general setup of all sequences for arithmetic. I'm going to use a in this context. What we're about to do now is make an equation where a is a function of n, meaning that the stage number tells me how many bars it's going to be. What that means is if I plug in 1, my answer should be 5. If I plug in 2, my answer should be 9. Plug in 3, my answer should be 13. Plug in 4, my answer should be 17. Same thing, 5 for the stage should give me 21 for the bars. So we're going to write a sub n equals. What this is a notation that says the number of bars is based on this number. And we want to start with our starting number, which is 5. That's how many we started with. Right? How much am I going by? Well, each time I'm adding 4. Because it's adding, we're going to say plus 4. If I was subtracting, then it would be a minus. Now, this is an equation in terms of n, so I need an n in my equation. And you might notice that there's a little space in between here at the moment, and that's because we have an issue. And the issue is this. If I plug in 1 in place of n, whenever you put something in place of a letter, it goes inside parentheses. What we have then as an answer is 5 plus 4 times 1. Well, 4 times 1 is 4, plus 5 is 9. But I don't want 9, I want 5. Similarly, notice that when I do the same thing with a sub 2, we get 4 times 2 is 8, plus 5 is 13. But again, that's actually for the next stage. And the reason this happens is because we actually didn't add the 4 until the second stage. We didn't add 2 4s until the third stage. So I'm actually off by 1. So what I want to do with this n minus 1 is actually subtract 1 instead. And that's because I actually want 1 less of these 4s than the stage number I'm on, right? When I'm on 1, I actually want 0 4s. When I'm on 2, I actually want only 1 4. When I'm on 3, I've added 4 2 times. So that changes these other ones that we're starting with to look like this. And now 1 minus 1 is 0, times 4 is 0, plus 5 gives me 5. 2 minus 1 is 1, times 4 is 4, and then plus 5 is 9. And you'll see a similar idea when you plug in 3, 4, and 5 respectively for n. Notice the pattern here now. Every time I start with the starting number, and then it was plus 4 times some number. Notice this is how many times we had added 4. Notice that we had always added 1 less than the stage number that we were on. But I only added 4 once on stage 2. I've only added 4 twice on stage 3. The amount of times that we've added 4 is always 1 less than the stage number on. That's why we have this n minus 1 part in parentheses. So in general, it's your starting number and then your common difference, and then always n minus 1 when the first stage is starting at 1. And that's what we're going to write on this line with the stage n. And that gives us 5 plus 4 times the quantity of n minus 1. Quantity means parentheses around the n minus 1. We can then just use that equation to solve for stage 50. Right? We don't have to draw that out. We don't have to keep continuing this pattern. We want to be able to jump to stage 50. What we've just written is an equation, and that lets me, knowing any stage number, simply plug in that number in place of n to find that total number of bars. Take a moment and try to do that. Otherwise, that's going to look like this. We write 5 plus 4, parenthesis 50 minus 1. Notice that this 50 is in place of the n. That means wherever we saw n, we're supposed to put the 50. And it says 5 plus 4, parenthesis 50 minus 1. 50 minus 1 is 49 times 4, and then add 5. You can just simply type it in your calculator, and we get 201 bars at stage 50. Go right over there. Notice this equation is very handy because I could find any stage number, 38, 97. We don't have to make our table and continue our table. This equation lets us jump to any stage number we want to find the total number of bars. And we can use the general equation again to go backwards. If I know how many bars I have, I can find the stage number. Once you use this equation, plug in the number of bars that we know they have, and see if you can find what stage that is. Otherwise, that's going to look something like this. I have 61 equals 5 plus 4 times quantity of n minus 1. Notice that my answer here is 61. What I'm trying to do now is figure out, well, what would n be so that my answer is 61? Take a moment, try to figure that out. And when you're trying to figure this out, what you're thinking is, well, what does this even say? This says that we're going to do n minus 1, so some number minus 1 is multiplied by 4, and then we add 5. That's our order of operation. If you want to solve it then, what you do is you go backwards. So if you haven't tried, try now. Otherwise, that's going to look like this. First thing we're going to do is subtract the 5. Opposite of positive 5 is minus 5, right? When we said the original problem, we said we're going to do in parentheses first, so some number minus 1. That answer then is multiplied by 4, then we added 5. So if we want to go backwards, instead of adding 5, we're going to subtract 5. So if it's a positive, we subtract. If it was a negative 5, then we would have added 5. So let's do the opposite sign. This gives me 56 equals 4 times the quantity of n minus 1. And let's think about what we just found here. We said 5 plus something is supposed to be 61. Well, what is this something part? 5 plus what gives me 61? Well, that part is 56, right? 5 plus 56 is 61. So what we found that 4 times the quantity of n minus 1 is 56. This whole chunk is 56. So now we have 56 equals 4 times the quantity n minus 1. Again, 4 times something is 56. We need to figure out what this something part is. Again, 4 times something is 56, so we want to figure this out by doing the opposite sign. So instead of multiplying, we are going to divide. We draw a line underneath and have 56 divided by 4. We don't use the little divide sign, we use this line. Notice when it's a number, line, number, that means divide. Here we had number, number, line. This line here meant equal, but the brown line means divide. Fractions are just division. Top number divided by bottom number. So 56 divided by 4 is 14. Remember, what did we find? We found 4 times what is 56? Well, 4 times 14 is 56. Right? This n minus 1 part is a total of 14. And the last part now is just saying what minus 1 gives me 14. We should all know that. Again, since it's a minus 1, to undo minus 1, we're going to add 1 to both sides. And that means that 14 plus 1 is 15. So the 61 bars happen on stage 15. And this is essentially what we have to be able to do with arithmetic sequences. Have to be able to find these answers. Figure out the pattern, write a rule, use that rule to either plug in your stage number or know your bars or whatever picture thing you're using or number thing you're using. Solve backwards to find the stage. If you can do that, you can do this unit. Now let's take a look at number 2. We have puppies with 4 stages shown. See if you can fill in the table, figure out the pattern, fill in the general equation, stage 50, and after 63 puppies, what stage would you be on? Okay. Take a moment to try to do that. Otherwise, let's start by filling in the first 4 stages. Pause it and try, and then let's check it out. We see stage 1 has 1 puppy. The second stage has the 1 puppy, and then 2 more puppies. That's a total of 3. Third stage has my start puppy, and the 2 previous, and now we've added 2 more puppies, and that's a total of 5. On the fourth stage, we now have the same amount of puppies we had from stage 3, but 2 more on top of that, for a total of 7. So what is our pattern? Tell us our start number, tell us how much we're going by, and we would write we're starting with 1 puppy and we're adding 2 puppies each time. That means for stage 5 we would expect there to be 9. And my general equation then for the nth stage, again where the stage number is n and the number of puppies is going to be a. So we'll write a sub n equals our starting number of 1, then our common difference, in this case we're adding 2, so we're going to say plus 2. And then again, because we're starting at the first stage instead of stage 0, we have to do the n minus 1 part. And that's inside parentheses. So we have 1 plus 2 times the quantity, means parenthesis, n minus 1 parenthesis. We can verify that's correct by plugging in stage 1 for 1. 1 minus 1 is 0, times 2 is 0, plus 1 is 1. Plug in 4 in place of n. 4 minus 1 is 3, times 2 is 6, plus 1 is 7. Remember, it should give me these answers on the right for whatever n value I plug in for n. We can use that general equation now to solve for 50, right? I don't have to keep making this table. I want to be able to jump to any number. That's why we make this general equation. So take a moment, plug in 50 in place of n, and see what you get. Otherwise, that's going to look like this. We get 1 plus 2, parenthesis, 50 minus 1, parenthesis. Let's type in as the right side of the equation. This a sub 50 is just going to be our total answer at the end. Don't worry about it when we're doing the equation. This is a 1 plus 2, parenthesis, 50 minus 1, parenthesis. Type it exactly like it says on the calculator, on Desmos or any other graphing calculator. Should follow over operations. And we get 99 puppies for stage 50. Use the same idea then from this equation and see if you can go backwards to find if there's 63 puppies, what stage did that happen at? Try to solve that next problem. Otherwise, that's going to look like this as an initial setup. 63 equals 1 plus 2 times the quantity of n minus 1. So, before on stage 50, right, we plugged in 50 to find how many puppies there were, right? That's what we found. Now we know how many puppies there are, now we need to figure out the stage numbers. Now we need to go backwards. If you haven't done so, take a moment, try to solve this. Otherwise, ask yourself, what would be the first thing I should do? Well, we're going to subtract 1. This gives me 62 equals 2 times the quantity of n minus 1. Again, all we said is 1 plus something has to be 63. Well, what is this 2 times n minus 1 part? That's 62. Right, to figure that out, we do the opposite sign. Opposite of positive 1 is minus 1. Keep it equal. What you do on one side, you need to do on the others. Since these two sides are equal, you need to do the same thing on both sides of the equal sign. That's what keeps it still equal. Now 2 times something is 62. How would I get rid of this 2 times something? How do you undo times? Well, we would do what? Divide. This gives me 31 equals n minus 1. Again, we're dividing both sides by the 2. 62 divided by 2 is 31. Still have the n minus 1 part. Again, all you said is 2 times what is 62? Well, 2 times 31. This n minus 1 part is 31. And now 31 equals n minus 1. So what number minus 1 is 31? Again, to undo the minus 1, what should I do? We're going to add 1 to both sides. And we get that we should have 63 puppies at stage 32. Consider, does that sound reasonable? At stage 5, there's 9 puppies. At stage 50, there's 99 puppies. Since 63 is between the 9 and 99, my answer should be between stages 5 and 50. We would expect it's probably a little closer to the 50 side, right? Since 63 is a little closer to 99 than it is to 9. So it should be a little more than half. And we see indeed that is. So that seems like a reasonable answer. Before we do number 3, let's take a look at our arithmetic sequence note. Take a moment, try to fill in these notes as best you can with what you know so far. An arithmetic sequence is a numerical blank where the same number is being blank or blanked each time. That number is called the blank blank. It is represented by the variable blank. If addition is used, the common difference is blank. If subtraction is used, the common difference is blank. A term is any blank within the pattern. It is represented by the variable blank. The equation a sub n equals a sub 1 plus d, parenthesis, n minus 1, parenthesis. What does the a sub n mean? A sub 1, the d, and the n mean? Try to fill that in. Otherwise, at the beginning here, an arithmetic sequence is a numerical pattern where the same number is being added or subtracted each time. That number is called the common difference. It is represented by the variable d. If addition is used, the common difference is positive. If subtraction is used, the common difference is negative. A term is any value within the pattern. It is represented by the variable a sub n. That means big, regular A, small n. In the equation then, a sub n is our term value equals a sub 1 is our first term plus D. Now be aware, in formulas, the plus means that it's the same thing. So if it's adding 3 each time, we say plus 3. If it's a negative 7, we would say minus 7. A positive D means that it's whatever D is that number. If it's a minus, it would have been the opposite of that thing. And we'll talk about that later when it comes up. All you have to know is it's not always a plus, but it means that it is this number for D. D here is our common difference. Parenthesis n. N is our term stage. And then minus 1 parenthesis. This is number 3 from our Patterns and Rules of Arithmetic Sequences packet. Take a moment and try to fill in this table using the pictures of the snowflakes. Otherwise, we see that this first stage has 6 snowflakes, 1, 2, 3, 4, 5, 6. From the 6 that we had on the next stage, we see that we got 3 more. That's a total of 9 snowflakes in stage 2. For stage 3 then, we see we have our starting 6, and then we've added 3 2 times, or another 3 from our previous 9, which is 12 flakes in total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Assuming that pattern continues, where I'm adding 3, stage 4 should have 12 plus 3, which is 15. Stage 5 then would have 18, because again, we took 15, we added 3, we got 18. So, now we've done that, let's fill in the rest of this to get down to our equation. So the first question says, find the common difference to continue the table. The common difference, D is what? What do you think that is? You see that we're adding 3. Then you can say positive 3 or 3, doesn't matter. The reason we say difference is to find this answer. I would just take 18 minus 15. What is that? 3. 15 minus 12, 3. 12 minus 9, 3. 9 minus 6, 3. Typically, we're given the sequence already, which is why we have to find the difference. And normally we just take the known numbers, subtract from the previous number, and then say we get your common difference. So typically the sequence is already given, and we need to find the common difference, which is just taking 18 minus 15, 3, 15 minus 12, 3, etc. Next question, where does the sequence start? A sub 1. Well, A sub 1, sub 1 means the first number, stage 1, and that answer is 6. Using our common difference and our A sub 1, we can write our equation using the first term and our common difference. Write the equation in form A sub n equals A sub 1 plus D times quantity n minus 1 form. So we have A sub n, that's what our variable is, equals A sub 1. A sub 1 we said is 6. But then it says plus D again. Because it's a plus, it really just means whatever that number is that number. So since D is going up by 3, we're going to say plus 3. It then has a parenthesis, and then n minus 1, and finally another parenthesis. So my equation is A sub n equals 6 plus 3 times the quantity n minus 1. That quantity means parentheses around the n minus 1 part. Once we have our equation, we can easily solve knowing the stage number, which is our n, or knowing the flakes, which is our A sub n. Let's use that to answer these questions down below. We don't even really need to look at the rest of that table. We can use this to solve the other problems. So use our equation to solve the particular stage. In this case, I want you to tell me how many snowflakes are there going to be at stage 50. Ask yourself first, is stage 50 going to be the A sub n or the n? You see that the stage number is the n, so you're literally going to put 50 in place of the n. That gives me A sub 50. Notice I put 50 in place of the n. That means wherever we see the n, I'm putting the 50. So A sub 50 equals 6 plus 3 times the quantity, remember parentheses, 50 minus 1 other parentheses. You're literally just going to type in this right side, the 6 plus 3 parentheses, 50 minus 1 on your calculator and get the answer, which equals 153 snowflakes. I did show all the steps here, but literally I'm okay if you go from this first line, which is our work, to the last one, which is our answer. But I did show each step in case you're wondering. We start with the 50 minus 1 is 49. 49 times the 3 is 147. 6 plus 147 is 153. Again, all I really have to do is type in 6 plus 3 parentheses 50 minus 1 parentheses on the calculator. That's our work. Boom, answer is 153. For the next problem, then, use the same equation from above to find when the stage will have a particular value. So when will there be 75 snowflakes? So using this equation up above, the a sub n equals 6 plus 3 times the quantity n minus 1. We now are asking, where would this 75 snowflakes go? We saw when I knew the stage, that number went in place of the n. And then my answer, a sub 50, right, the answer to this problem was 153 snowflakes. Now I know the snowflakes, 75 snowflakes, and I'm trying to find the stage. So do I know the a sub n part, or do I know the n part? Take a moment and write down if you think this equation will look like. Otherwise, we get 75 equals 6 plus 3 times the quantity n minus 1. Now that we have that equation, let's see if we can solve for n. So what stage number n will make my answer be 75? So what number, if I plugged it in place of n, will give me 75? Take a moment and try to solve that. Otherwise, we see that our first thing we should do to solve this problem is to subtract 6. We have a positive 6, so we're going to subtract 6 on both sides. Remember, we have 75 equals 6 plus 3 times n minus 1. Because it equals means that whatever we do on one side, we need to do on the other side to keep it equal. 75 minus 6 is 69, which equals 3 times the quantity of n minus 1. Remember, all we did here is said 6 plus what is 75. Well, 6 plus 69 is 75, right? So the 3 times the quantity n minus 1 part, this part right here, is equal to 69. That's what you just found. Now you're saying 3 times what gives me 69. So what does this parenthesis part have to equal? 3 times what? Remember, if you don't see a plus, you don't see a minus, you don't see a divide between the 3 and the parenthesis, between a number and a parenthesis, it's implied that we're multiplying. So how do we undo multiplying? Well, we divide. Dividing both sides by 3 then, we get 69 divided by 3, which is 23. 23 on the left. On the right, 3 divided by 3 is 1, so all we're left with is the n minus 1 part. So again, we found 3 times what is 69? 3 times 23 is 69. So this part, the parenthesis part, has to be a total of 23. And now the last part is n minus 1 is equal to 23. So something minus 1 is 23. Well, what does this something have to be? Again, to undo minus 1, we're going to add 1. 23 plus 1 is 24, so that means that there will be 75 snowflakes at stage 24. So let's fill in the rest of our table if we're doing the packet. And that's how we do problem number 3. Your job is to finish the rest of the packet.